questions 21 through 25 on the 2020 Grade 8 Gauss Math Contest. The ratio of green balls to yellow balls in a bag is 3 to 7. When 9 of each color are removed, the ratio of green balls to yellow balls becomes 1 to 3. How many balls were originally in the bag? Green to yellow is 3 to 7. And then once you subtract 9, it would be g minus 9 over y minus 9, and that ratio is 1 to 3. So we just have to solve this. 7g is therefore equal to 3y. When you cross multiply here, you get 3g minus 27 is equal to y minus 9. Let's isolate for 1 and substitute. So we can say that 7g over 3 is equal to y, and then substitute that in that equation. So this will be 3g minus 27 is equal to 7g over 3 minus 9. And if we multiply through by 3 to get rid of the fraction, we have 9g minus 81 is equal to 7g minus 27. So that means 2g is equal to 54, and therefore g is equal to 27. And then when you substitute back into here, you will get y is equal to 63. So the total number of balls in the bag originally is basically g plus y. So that's 27 plus 63, and that is equal to 90. So number 21, the answer is B. 3 spinners are shown. The spinners are used to determine the hundreds, tens, and ones digit of a 3-digit number. How many possible 3-digit numbers that can be formed in this way are divisible by 6? All right, so we have to choose one number from here, or one number from here, one number from here, that kind of story. Well, we have 4 choices here, 4 choices here, and 4 choices here. So 4 times 4 times 4 is 64. So that's quite a bit. Is there any way I can eliminate any of these? And I think I can, because if a number is divisible by 6, and you can do this in your calculator, the numbers, the last digit of the number, also known as the units digit, will have to be, let's see here, either 6, I'm just going up by 6, 12, that's 2, 18, the units digit is 8, 24, units digit is 4, and then 30, units digit is 0, then 36, 42, 48, 54, and then 60. Again, you'll see 62840. So 62840 are the only possible units digit of a number that is divisible by 6. So this last digit cannot be a 1 or a 3. It can only be from this particular list, the 0 or the 2. So I've only got 2 choices for that last number. So that helps a little bit to cut it down. So 4 times 4 times 2, that's 32. Well, 32 is not that many, so I can list them out. So let's start with that list. 4, 4. Next number 5, 5, and then 0, 2. 4, 4. Next number from this, I'll choose 7, and then 0, 2. 4, 4. Next number 6, and then 0, 2. And then 4, 4. Next number 8, and then 0, 2. And you're getting the hang of this. So I'm just going to write out all the 32, and then I'll come back and I'll start talking about the divisibility. So, as previously stated, there's going to be 32. Now all we have to do is just look at which ones are divisible by 6. And you don't really have to look at every single one and divide by 6 on your calculator. You can kind of look at it from the sense of like a pattern, right? If a number is divisible by 6, then it'll just be divisible by each additional 6 that you add to it. So, for example, if a number is, say, 30, then 36 will be divisible by 6 because you added 6, that kind of thing. So a lot of these numbers are very close to each other. So if one is divisible by 6, you just add and subtract 6 to get the other ones. So for example, 450 is divisible by 6. So 456 would be divisible by 6. You see what I'm saying? 462, which is right here, then 468, and then 474, and there is no 474, and then 480, and there is a 480, and then 486. So in a very quick way, you can do it like that instead of dividing every single number by 6. Okay, let's start talking about the 300s. Well, 360 I know is divisible by 6. That's pretty obvious. So let's go down first. 354 and 348. There is no 354, no 348. Let's go up. 366, 372, 378, 384. So those are the only two. And you get the hang of this, right? So in the next list, it's 252 and 270 that are divisible by 6, and 282. And in the last one, it's 150, 162, and 180. So how many did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of those are divisible by 6, therefore number 22, the answer is A. In the diagram, rectangle PQRS has PS equal 2 and PQ equals 4. Points T, U, V, W are positioned so that RT equals RU equals PV equals PW equals A. If V, U, and WT pass through the center of the rectangle, for what value of A is the shaded area 1/8 of the area of the rectangle PQRS? Well, the first thing, let's label this. This whole side is 4. This whole side is 4 and 2. And then this is A, these distances. And similarly, this and this is also A. So A is here and A is here. And then this point right here is the center. So we should draw lines through the center like that. And then to figure out the area of the shaded region, we definitely should draw another line down the diagonal like that. And then what that does is it splits it up into 4 triangles. So here's the first triangle, second triangle, and third and fourth triangle down there. Third and fourth triangle. Okay, so we can now figure out this area. First of all, what is the area of the whole PQRS? Well, that's pretty straightforward. That's just 2 times 4, which is 8. So the area of the shaded region is 1/8 of that. So 1/8 of 8, which is just 1. So the area of the shaded region has to equal 1. So 1 has to equal, let's see, this triangle can be calculated as 1/2 base times height. 1/2 base, which will be right there, which is A. And the height can be from here to here, or from here to here, whichever one you want to choose. And that's going to be half of this 2, so that's just 1. And now we move to this triangle. That one, 1/2 base times height. This is the base, and this time this is the height, and that's different. That's 1/2 of 4, so it's A times 2. These two are pretty much the same as the ones I just did for the same reasoning. So again, we have another 1/2 A times 1, and then we have another 1/2 A times 2. When you add all these up, you will get A plus 1 plus 1, 2A. And that's just 3A. And that equals 1. Therefore, A is equal to 1/3. So, number 23, the answer is D. Every 12 minutes, bus A completes a trip from P to X, to S to X to P. Every 20 minutes, bus B completes a trip from Q to X, to T to X to Q. Every 28 minutes, bus C completes a trip from R to X to U to X to P, R. At 1 p.m., buses A, B, and C depart from P, Q, and R respectively, each driving at a constant speed and each turning around instantly at the end point of its route. Each bus runs until 11 p.m. At how many times between 5 p.m. and 10 p.m. will 2 or more buses arrive at X at the same time? Well, we need to make a table. And let's first talk about this. So our starting point is 1 p.m. And that's where we have P. And then I'm just going to write the numbers, make it a little bit faster. So at exactly 3 minutes later, it'll be at X, then 3 minutes later at S, then 3 minutes later at X again, and then finally at 3 minutes later back at P. In 12 minutes, it makes that journey. And in a very similar way, if you keep going 15, 18, 21, and 24, it would again be X, S, X, P. So obviously, it's at X at these times. And as you can clearly see, it starts at 3, but every 6 minutes it's back at x. In a very similar way, we'll do the story for bus B. It starts at 1 p.m. and it is originally at Q. And then every, let's see here, 20 minutes, so you got to divide that by 4. So every 5 minutes, so 5, 10, 15, and 20 is where it meets at x, t, x, and then back at Q again. And in a very similar way, every 5 minutes after that, 25, 30, 35, and 40, it would be at xt, xq, xt, xq, like that. So here, as you can clearly see, you start at 5 minutes, but then every 10 minutes after that, you're going to be back at x. Same story for C, slightly different numbers though. This time it's r, xu, xr, and then it's 28 minutes every 7 minutes. So 7, 14, 21, 28 is your r, xu, xr. And then 35, 42, 49, and 56. XU, XR, like that. All right, so that means every 7 minutes, it starts at 7, but then every 14 minutes, it's going to be at X. All right, so we have covered that. Now, it starts at 1, and then we want between 5 and 10. So just be careful here. It starts at 1 p.m., and I'm going to convert everything to minutes to make it easier. 5 p.m. is 4 hours later. So write that here. 5 p.m. is 4 hours later. So 4 times 60 is 240 minutes. So this is where it begins in terms of where we want to look at when they meet. Between. And then 10 p.m., that compared to 1 p.m., is 9 hours later, right? And 9 hours is 9 times 60, which is 540. Like that. So we want to look at times in between 240 and 540. Okay. Well, at this point, you're just adding 6 every time. So if you just kept adding 6 to 21, actually adding 6 to 3, really, that's the starting point. You eventually get to where we are. And the first time you get above 240 is 243. And then 249, you're just adding 6 every time, ... You just keep adding 6 every time. And then you eventually get to 537. That's the last time before 540, which represents our 10 p.m. So you can make a little formula. It's really 243 plus 6K. And that's a pretty straightforward formula. So same thing here. We want between 240 and 540 minutes. You're starting with 5 and you're adding 10 each time. So the first time you get above 245 is, the first time you get above 240 is 245. And then you're adding 10 each time, so 255, ... And then eventually you get to 535, which is the last time before 540, which is 10 p.m. So this formula is 245 plus 10K, or 10M. Let's use different letters because it's not necessarily going to be the same value. Okay, by now I think you're an expert. This is 240. This is 540. You are starting at 7. You're adding 14 each time. And then when you keep doing that, eventually you get to 245 as the first time, and then 259 because you're adding 14 every time, and then ... And then eventually you get to 539. So right before our 10 p.m. cutoff. And this one is what? 245 plus 14N. All right. So we have established that. So the question basically boils down to saying, when do we have 243 plus 6K, which is bus A, equal to bus B, which is 245 plus 10M? Also, the question is saying, when is bus B equal to bus C, which would be 245 plus 10M is equal to 245 plus 14N. And then one final comparison would be A equal to C. and that would be 243 plus 6k is equal to 245 plus 14n. All right, so let's do those three, and that should be sufficient to figure out our answer. All right, so here we go. The first one, this one right here, that one gives us, let's see here, 6k minus 10m is equal to 2. Divide through by 2, and I get 3k minus 5m is equal to 1. So now I'll make a little table, k and m, and try to get integer solutions. So start plugging away, and 2 and 1, that will work. 7 and 4, 12, and 7, and so on. You can pretty much get a very quick pattern. It looks like it goes up by 5, so 17, 22, 27, yeah, 32, 37, 42, 47. And then I'm going to put the time, because the time's important. So for example, when k is 2 and m is 1, when k is 2 and you plug it into there, you get 242 plus 12, which is 255. So I'm going to put the time here. Actually, it's not 255 in terms of the time, like 2 hours and 55 minutes. It's 255 minutes. So I just want to make that clarification. Okay, very similarly, you do the same thing, and you get 285, 315. These are minutes, of course, 345 minutes from this 1 p.m. Let's see here. I'm just got to make this match here. 375, 405, 435, 465. Are we adding 30 every time? Yeah, I could have just added 30 every time. 495, and then 525. Okay. So how many did I get? Because if I go another 30, I'll be at 555, and that goes above my boundary, which was 540. So I got to stop at 525. All right, so how many did I get here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 10 times that bus A meets bus B. So let's now go to bus C and B. So this gives me 245. Oh, those cancel. So it's just 10m is equal to 14n. Okay, and then I guess I can divide through by 2. 5m is equal to 7n. So again, make a little table, and off we go. So it looks like the first solution is 0 and 0. That's helpful. And then 7 and 5. And then I think just multiples. So 14 and 10, 21 and 15, 28 and 20. And then after that, I think it'll be above the 540. Let's just write out our times. This one is just 245. When m is 7, and we put in there, it's going to be 70 plus 245, which is 315. And then I think I'm adding 70 each time. So 385, 455, and then 525. And then that's basically at the cutoff, because the cutoff is 540. So here I got 5. But we got to eliminate doubles. That's the key to this question, in my opinion. 315 has already been counted, and so has 525. So 315 here, I cannot count again as a unique spot or time. So I only really have 3 new ones. So I got to put that here. Only 3 new. So these 3 are the ones that I'm going to count in my cumulative total. All right, one last one. This one gives me 6k. Let's see here. 6k minus 14n is equal to 2. That means 3k minus 7n is equal to 1. All right, same thing here. We've got to make a little table, and off we go. So we get integer solutions as following. 5 and 2, 12 and 5, 19 and 8, and I think it goes up by 7 each time. So 26, 33, 40, 47. And I think after that we meet the cutoff. So the times, plugging back into here, for k is 5, it'll be 243 plus 30, which is 273. And then same thing, 315, 357. It looks like I'm adding a certain, 42 I think I'm adding every time. Yeah, I think so. And then 399, 441, 483, and then 525. And then if I add another 42, I'll go over that 540 boundary. Okay, so I got 7 here, but again, 315 and 525 are already counted, so I already got 5 new. All right, so now I'm ready to add my total, 10, 3, and 5. So that is 18. So 18 times those buses will meet, and therefore number 25, the answer is A. A sequence of positive integers with 20 terms is called an FT sequence if each term after the second is the sum of the previous two terms. For example, if the first two terms of an FT sequence are 8 and 7, the sequence would begin 8, 7, 15, 22, 37, so on. For some positive integer m, there are exactly 2, 4, 1, 5 FT sequences where the first two terms are each less than 2m, and the number of odd valued terms is more than twice the number of even valued terms. What is the value of m? We have a long list of terms. Each term is one of this sequence of 20 terms. So it's a very long, so I'm going to put ... obviously. Now we have to start understanding what this question is actually asking us. We have to start with two terms. And with those two terms, we are going to create this sequence, which basically is as follows. If the first term is, let's say, A, the second term is B, then each term is basically an addition of the previous two. So this would be A plus B, this would be A plus 2B, which is the sum of this and this. And then the next term would be the sum of the previous two, which would be 2A plus 3B, and so on, right? Now, we are told a very interesting point that the number of odd valued terms is more than twice the number of even valued terms. All right? At first, you think, okay, what does that even mean? Well, of these 20 terms, you're going to have a certain number that are odd and a certain number are even. So let's say of the 20 terms, x of them are odd, and therefore 20 minus x, the remaining terms are even. So what that sentence really means is that x is greater than 2 times 20 minus x. This sentence right here, the number of odd valued terms is more than twice the number of even valued terms. So we have to basically concentrate on odd and even in this question, interestingly. What the numbers are in terms of their numerical value is not really that important. What's important really is just whether they're odd or whether they're even. So let's first talk about what happens when you add two numbers. If you add two numbers and they're both even plus even is even. If you add two numbers, one is even and one is odd, the result is odd. If you add, again, two numbers and then you just reverse the order, the result is the same. And then finally, the last one would be two odds added together, and that result, interestingly, is even. So this one we don't need to worry about, because if we're going to just put even and then the result is even, so for example, if this was even and this was even, then the result is even, then again you get even and even. You just keep getting even numbers and you never be able to get any odd. So you never be able to satisfy that inequality. So this one, no good. Let's talk about the next one, even and odd. So let's say this is even and this is odd. Then when you add an even and an odd, the next one would be odd. All right, so that's the pattern here. Then you add two odds, these two, and you get an even. Then you add an odd and an even, and you get odd. And then you just keep going like that. You don't need me to talk you through it. So it's EOO, EOO, like that. Now, we're going all the way to the 2020th term. So this EOO, EOO, EOO will keep continuing, right? Now, what happens at the very end, though? Well, if this number was perfectly divisible by 3, it would just end as EOO. But it's not divisible by 3. 2019 is divisible by 3. So that basically means that this ends like this, because this is the 2019 term. And the very last one will be E, because it's part of the EOO repeating sequence. Okay, now let's talk about odd and even. Odd and even for scenario number, I'll just call it scenario number 1. How many odd and how many even do we have for this scenario? Well, I'm just going to concentrate on the 2019, and then we'll add one extra E at the very end. There's 2019, and each of them are broken up into segments of 3, right? EOO, EOO. So first take 2019 divided by 3. And when you do, you get 673. So that means there's 673 of these EOOs. Well, that means there's 673 E's, because each of those EOOs has one E. 673 goes there. And then how many odds? Well, each EOO has 2 O's, so 673 times 2 would be the number of odds. And 673 times 2 is 1346. But don't forget the last E, so that's going to add here. So to make that 674. Okay, so now we have to go back and see if that inequality is satisfied. 1346, is it greater than 2 times 674? That would mean 1346 has to be greater than 674 times 2 is 1348. And that is not true. So that is no good. So scenario number 1, no good. We can't have a sequence that begins like that. All right, no problem. Let's keep going. We have another way of doing this. Another way of doing it would be, instead of putting E first, I can put O first. So that means instead of EO, it would be OE. So odd and then E. And then now let's just use our rules here. I mean, you don't really need to memorize them. I'm sure you know them by heart. Odd plus even. Odd plus even is odd. Even plus odd is odd. Odd plus odd is even. Okay? Odd plus even, that's odd. Even plus odd is odd. All right. It looks like another EOO situation. The only difference is this time it's shifted a little bit. We started with an O, and then it's EOO, EOO, and so on. All right, so let's make a little bit of space, since I don't really even need that, since I had already mentioned that we're not even going to care about that even plus even stuff. So let's get down to the very last 4 and see what happens. It looks like, since it's being shifted 1 to the right, it will just end up as EOO like that. All right, perfect. Now let's go back to our table and let's figure out what this called scenario 2. So let's figure out what our scenario 2 is. How many odd, how many even? It's the same story, actually. I think you can do this. There's 2019 numbers, if you don't count that one, because that's sort of like the odd one out, right? So the 2019 divided by 3, I had written that in, it's 673. So that basically means that there's 673 of these EOO sequences. Each of those gives one E. So there's 673 E's. Remember, odd and even. And then how many odd are there? Well, each of those 673 gives 2 odds. So 2 times 673 would be the number of odds. And then don't forget, there's one extra one at the very end. So when you do that math, 673 times 2 plus 1 would give you 1347. Okay, so now we have to see if this inequality holds true. Is x greater than 2 times 220 minus x? Okay, so that means 1347. Is it greater than 2 times 673? That means 1347 would have to be greater than 1346. And the answer is yes. Great. So I will accept that as a possible way of doing this. And then, of course, we have one more situation. We started off with this one, EO, which was this one right here, EO. We then did OE, which is this one right here, OE. And now we have to do the third one, which is odd, odd, as the first two. So OO, like that. All right, let's make this list. OO, E. Then O plus E is O. E plus O is O. OO is E. Okay, so this just goes OOE, OOE, like that. All right, and then when I get all the way dot, 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 all the way down to the last four, what do I have? Well, very similar to before. This is the final one, right? That's to the 2020th, and then this one is the 2019. Because 2019 is divisible by 3, the last 3 until 2019 will be OOE, because 2019 divides into 3 perfectly. And therefore that 2020th will be O. Okay, same story. How many O's and how many E's? So we got 3. Scenario 3. How many O's and how many E's? Well, again, 2019 divided by 3 is 673. For each one of those 673, we get one of these 3 segment sequences, and each one gives 1 E. So there will be 673 E's. So 673 E's, evens. And then for the odds, of those 673 strings, each will produce 2 odds. So 673 times 2. And then don't forget that one odd man out at the very end. So 673 times 2 plus 1, and that is 1347. So 1347 goes here. So we have to now check this inequality right here to see if it's true. Is 1347 greater than 2 times 673? And the answer is yes. The answer is yes. I can cheat a little bit because I've already done that up here. It's pretty much the exact same mathematics. All right, so that concludes that part of the question. Now I know which ones to choose. I can either choose this scenario or this scenario. All right, so now we have to figure out what is M. Let's go back and figure out what M is. For every positive integer M, there are exactly 2, 4, 1, 5 sequences where the first 2 terms are each less than 2m. Okay, less than 2m. So let's just start with an answer choice. I think that is the best way. Will make it clear. If I start with m, it might get a little too abstract and I might lose you. So I'm going to just start with a number. Let's say m was equal to 21. So that means that each of those first 2 terms, A and B, which is what I called them, each is less than 2m. So A is less than 2m, which is 42, and B is less than 2m, which is 42. Okay, now let's talk about scenario 2 and then scenario 3. Scenario 2 and scenario 3. Scenario 2 and scenario 3. So scenario 2 basically says that there has to be an even as my first and then an odd as my second number, which is right here. Or either way, I mean, I just reversed it, but I think it's important that you not reverse it. So let's keep an order here, odd and then even. So it's very important that you do not reverse it, because this is valid, but this is not. All right? So be careful there. Now, I have to figure out how many A's are there and how many B's are there. Well, A is less than 42. A is an odd number. How many odd numbers are there less than 42? You tell me. Well, 41 is the largest one, and then you just keep going down, right? 39 and then 37 all the way down to 1. That, if you do the counting, or you can do it in your head, gives me 21 possible numbers. Now let's do the same thing for B. B is an even number, and B is less than 42. How many even numbers are there less than 42? Well, you're starting with 40, and then basically from 1 to 40, how many even numbers? Well, you can just divide by 2. That makes it easy, right? That gives you 20. So 20. So that's basically how you would do this. And then all these other numbers will originate from those first two. So we only need to worry about the first two. There's 21 possible choices for A and 20 possible choices for B. And that gives me 21 times 20, which is 420. Okay, now we'll do it for 3. This scenario right here. This scenario basically was this one right here. Odd and odd for the first two. So that means A is odd and B is odd. Okay, same numbers. You tell me, how many odd numbers are there less than 42? Well, I kind of gave you the answer about a minute ago. There's 21. And how many odd numbers are there for B less than 42? Well, it's the same, 21. So we got 21 times 21, which is 441 possible ways of placing this number and this number together. Okay, so now I add these two. And when I do, I get 861. Okay, that's great. But here's the thing. That number has to be 2415. And you say, okay, well, do I have to do this for every single one? No, not really. I just wanted to illustrate it with a number to make you understand. Because if I used M, it would be a little too abstract. Okay, now that you're an expert, we can figure this out using M's. It seems to me, and look at the numbers will help tremendously. For any M, it looks to me that this is M and this is M minus 1. So this multiplication would essentially just be M times M minus 1. And then for this, it looks like this is M, and then therefore this multiplication is just M times M. So I conclude that M times M minus 1 plus M times M, which is M squared, that must be equal to my 2415. When I set M equal to 21, I fell short because that sum is only 861. But this equation should allow me to get the exact value of M. That gives me the sum that I require. Okay, you can either factor this or do a quadratic. Here we go. So this will be M squared minus M plus M squared is equal to 2415. 2M squared minus M minus 2415 is equal to 0. I don't feel like factoring because off the top of my head, I can't figure this out. So no problem, use a quadratic. M is equal to minus B plus or minus the square root of B squared minus 4AC. And on the Canadian exams, you're allowed to use a calculator. So this will be 1 plus or minus. When you do that and you take the square root, you get 139. Very nice integer. And then obviously, you're going to take the positive one. So 1 plus 139 divided by 4 is 35. And there you go. That is the answer to this very challenging question because this comes from a grade 8 math contest. That is elementary school. Number 25, the answer is D.